Hi everyone, welcome to these Python tutorials where we are putting special focus on image processing related tasks. In this video, let's talk about callbacks that we can use as part of our Keras training model fitting. And we can use that for checkpoints and also early stopping and a couple of other tasks. What do we mean by all of this? That's exactly what this tutorial is about. First of all, callbacks are objects in Keras that can be used to monitor certain metrics and perform certain actions during the training. So callback is a way for us to kind of monitor these metrics as we are training and then perform certain actions. And we'll see that. And model checkpoint is one of those actions. Model checkpoint is a callback. Okay, so when you're training a model, you supply callbacks to it. And callbacks is a list of things that you would like to do as the model is training. And one of those things that you can do is something called model checkpoint. It's basically a callback, and it's used to save the training model during training. While the training is happening, you're like, I want to save the model. Now, early stopping is also a callback. So you also supply early stopping as a callback. Why? To stop the model training early based on certain conditions. That's, pretty clear from the name, early stopping. Now, as part of early stopping, you can monitor validation loss, right? As each epoch goes by, you're monitoring something, some of these metrics. Let's say you're monitoring validation loss for every epoch, and that can be used as a metric to make a termination decision, meaning, hey, if you go 200 epochs, the model may overfit, right? But the model is probably perfect after 50 epochs. How about saving a model right at that point? Because now you're monitoring validation loss, and if the validation loss goes up, you want to stop it. But then how do you know that is the minimum if you don't see 5 or 10 epochs after? That's where the patience value comes into picture. As part of this early stopping, you can give what metric to follow and also what the patience value is. If your patience is 10, that means once a decision is made in terms of, hey, this is the minimum, this is where I want to save the model, it still goes 10 epochs later and then confirms that this is indeed the point where we have reached the lowest validation loss. So let's look at these, and there are a couple other callbacks we'll see later on, but I just want to make sure you understand the common terminology: callbacks, checkpoints, and early stopping. Okay, so let's jump into our Google Colab and put this to action, and this will be a relatively quick video, I hope. And here is the code that we have been using, and this is again our CFAR10 dataset. And let's connect to, we're all connected. So let's go ahead and run these lines, and no need to explain each of these. We have looked at this many times. So let's use all of our 50,000 data points. So I'm downloading this CFAR10 from keras.datasets. And now let's go ahead and view a few images. I always do this no matter how many times because it's very satisfying, first of all. But more importantly, it tells us everything is okay. It's like a sanity check. Now let's go ahead and scale the values by dividing the pixel values by 255. Very important. Again, we talked about this in the past. And let's convert our Y values to categorical. Again, we talked about this in the past because this is multi-class classification. So let's print this just to confirm. Yes, that is. And now let's create a model with. Okay, let's go ahead and use 0.5. I was wondering why we used 0.5. Apparently with 0.5, you get, the model stops when it encounters a bit of overfitting. We could have actually dropped this to 0, for example, where we definitely see overfitting, but let's not deliberately make our model bad. So this is our one of the models with only 2 convolution layers, or blocks, I should say, not layers. And there it is. Now, how do we define the callbacks? Here it is. From keras.callbacks, import model checkpoint, early stopping. I'm also importing something called CSV logger, which is basically it stores your parameters, loss and accuracy as a CSV file. So if you want to plot it, you can plot it outside of this. Okay. Now, so first of all, let's define model checkpoint, which means we are saving this model. Saving where? We have to provide a path. So let's go ahead and provide a file path as, okay, let's do one thing. Let's make it fun. Let's actually define a file path in my notebooks, I'm giving this saved models. Right now we should have nothing. This is brand new. I should have ran this at least once on Colab, but I'm hoping everything works out fine. So here I'm saving the models with a unique name. Every time it actually finds a good model, it saves it with this name. It saves it with epoch number and what accuracy did it actually get. This means I may end up with 20, 25 different models because every time it's a unique name. If you don't want to do that, then you can actually just give a single name called bestmodel.hdf5. Then every time it just overwrites that model. I hope that's clear. Now the checkpoint here is model checkpoint file path, right? So the model checkpoint is the checkpoint we are trying to define where to store my file path and what to monitor validation accuracy, because that's what we are, one of the metrics is accuracy. If your metric is IOU or something else, obviously that's what you will be monitoring, a logical choice. Verbose equals to 1 means show things on the screen if you're saving something. Save best only equals to true means instead of saving everything, as it sees better and better models, it saves the best only. That doesn't mean you only have one. It's like if my iteration 1 is a good model, it saves it. Iteration 2 is better, it saves it. Iteration 3 is not better than 2, it doesn't save it. Iteration 4 is better than iteration 3, it saves it. So you'll end up with a lot of files if you have this type of file name. Okay, and moving down, early stopping. Now let's define early stopping. This is a bit more straightforward. What do you want to monitor? Validation loss. Patience, 3. That means go 3 epochs after you find it and then confirm it. Usually I like a number of 10 or 15 or 20 for patience if I'm doing 100 epochs or so. And again, print things on screen as you're doing it. And log CSV logger is very straightforward. CSV logger is where do you want to save the CSV file and what separator, comma separator, or what separator you would like to use. And finally, you can have a bunch of your callbacks, right? I mean, you can have, in this example, I have checkpoint, early stop, and log CSV. I'm defining a list of all of these and calling this callbacks list. Okay, let's go ahead and run this. This is a callbacks list. Where do I supply that? As part of model.fit. Okay, here I'm giving it callbacks list. That's it. Now, when you run this, let's see how the progress looks like. And we should be seeing saved models as part of our saved models, and I'm saving the logs as part of saved logs here on my Colab notebook. Saved logs and saved models. Logs get saved after the entire training is done, and model gets saved. If I'm right, model gets saved after every epoch. We'll check that in a second. Not sure why it's taking a little bit of time, but let's keep an eye on this. Okay, there you go. It started. And as soon as the first one is done, it should probably save the model because that is the best one until that point, right? So it says, hey, validation accuracy improved from -infinity to whatever that value. So saving the model. Okay. And now it's saving the model again because it improved. You see how the model is saved. It's called weights improvement, 0.1 for epoch number 0.1 and 0.33 is our accuracy right there. Okay, now if I go to saved models, you should see that models are saved one after the other. So this can fill up your space, so be careful when you do this. Now that's why sometimes, most of the time, I just give a single file name, so that gets overwritten and I only have the best model and nothing else. Okay, so let's let this run, and you see the accuracy is improving, right? So 52, 53, 55, now it is 57. And let's monitor this. I want early stopping to kick in at some point. 59.6, that's still working. And what is our criteria for early stopping? Validation, monitor the validation loss, and patience equal to 3. So let's monitor the validation loss, 1.16. Actually, it jumped up here. You see, it did not improve, so it did not save the file. And then at 1.11, 1.10, it keeps going. And I hope this stops at some point. Validation improved, so it saved the file. Okay, so let's see how one more iteration, and then I'll probably pause this video and then continue as soon as I see early stopping if it decides to stop early. Okay, so here apparently we are still getting better, as you can see. So this is not a right test. So one more thing what I'll do is, again, I'll pause the video, so don't worry about it. One thing I would like to do here is change the dropout to 0.0, so we get a bit of overfitting going on, and see if that actually helps. So let's go ahead and restart and run all, so that way we don't have to do one cell at a time. So I'm going to pause this video again. Let's go ahead and see if early stopping is going to help, because I really want you to see that. If not, you can go ahead and test it on your own data. But let me pause the video right now. Okay, so I guess in this case, obviously we don't have any dropout. So it started to overfit at an early stage. So it stopped, and you see it's at early stopping. Why did it stop? Because it saw this 0.8783 validation loss at an epoch of 11. And then it said, okay, let me go to 12, increased at 13, increased at 14. So 3 epochs later, it just said, okay, stop, and that gets saved. Okay, so if we go back here again, I have a whole bunch of these. I'd probably use the last one, right? I mean, this is, or whatever the one at 17, wherever we saw this, like epoch number 11. So let's use the epoch number 11, and everything else we can go ahead and delete this. So for now, let me go ahead and delete all of these just in case. Don't want this to take up too much space. But if you go to saved logs, then here you can see my logs, and then it'll I mean, this is just a CSV file, like I said, with okay, for some reason it got stuck, but you can see with all the losses and accuracy values. Okay, so I think this is pretty much it for this video. Again, like I promised, this is going to be a short video, but hopefully very informative, and this is going to save you a lot of time in not worrying about I should have done more epochs. I'll also talk about how you can continue learning or training your model if you think that you need more epochs. Okay, it's upcoming in one of the upcoming tutorials, but the best way to do that is give a lot of epochs and then just use early stopping. Okay, in the next video, let's go ahead and look at how we can use one of the callbacks called learning rate scheduler, and then schedule a learning rate. So the learning rate gets updated as your epochs just go, because one standard learning rate, one constant learning rate is probably not a good idea. Okay, so please stay tuned for that video, and again, subscribe to this channel so you get notified when that video gets uploaded. Thank you.